Hello, this is Mr. Collier, and today we're going to be finding unknown side lengths using trigonometry. So in these questions we have an angle in a right triangle, we have one of the sides in a right triangle. We can use that information to find the missing side lengths in triangles. Okay, so we're going to use trigonometry to do that. Firstly, I'm going to write out my trigonometric ratios in the form of SOHCAHTOA. Okay, so if you remember this, you can remember your three main trigonometric ratios. So SOHCAHTOA tells you that sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So if you look at this question here, in order to figure out which ratio I'm going to use, sine, cosine, or tangent, I'm going to look at the information given. So here's the angle that we're given, and if we should probably label the size of the triangle. Firstly, the 10 over here is the hypotenuse, and with reference to the 20-degree angle, x is going to be opposite, and this side here is going to be the adjacent. We're not going to use that one because we don't even have any information here. So what we're going to use is opposite and hypotenuse. Okay, because we have one of those and the other one is our unknown that we're looking for. So if you look at the ratios, which one uses opposite and hypotenuse? That would be sine uses opposite and hypotenuse. So we're going to use the sine ratio to find x. So let's write down what the ratio means. So sine, and our angle is 20 degrees, so the sine of 20 degrees is the ratio opposite divided by hypotenuse. Which, well, let's write that out. Opposite divided by hypotenuse. So sine 20 degrees equals, and the opposite is x, the hypotenuse is 10, so you're going to have x out of 10. In order to solve for x, I'm going to multiply both sides by 10. So I'm going to times by 10, times by 10, these 10s cancel, and then I get the equation x equals 10 sine 20 degrees. Okay, and if we work that on our calculator, we'll get, so we need to do 10 times sine 20 degrees. Okay, and that equals about 9.1. We'll round it off to nearest tenth here. That's about 9.1. About 9.1 meters. Let's check for reasonableness. Hypotenuse is 10. X is 9.1. Does not seem reasonable. I got this answer, x equals about 9.1. And actually it doesn't seem reasonable because this is a 20-degree angle. This side should be a lot smaller than 10 meters. Okay, it looks a lot smaller than 10 meters. So I think I made a mistake, and I'm going to show you this because this is the mistake a lot of you are probably going to make. You have to be very careful when you do these trig problems. You want to make sure that you are in degree mode and not radian. So if you look here on this particular calculator, you've got radian and you've got degree mode. You want degree mode because we're dealing with degrees. Okay, so I need to switch that to degree. Okay, so now we're on degree mode, and I'll quit that. Let me do that again. 10 sine 20 equals, and we get 3.4, which looks a bit more reasonable for our triangle. So I'm going to erase that and put down the correct answer, which is 3.4. So let me go back here. That is 3.4 meters, which seems a lot more reasonable. Okay, so now we got our calculator in degree mode. We should get all the right answers for these questions. So in this triangle, let's look at this triangle. The reference angle is 50 degrees. Okay, of course y is the hypotenuse with reference to 50 degrees. 15 is going to be the opposite, and this one's going to be the adjacent. So again, we've got opposite and adjacent, so again we're going to use sine. So we're going to have sine 50 degrees equals equals opposite. Now let's be careful about this one. Some people like to automatically put the y out of 15, but we got to follow the ratio. It's opposite over hypotenuse, so it's going to be 15 out of y, the other way around. Sine 50 degrees equals 15 out of y. We can solve for y by two steps. Let's multiply by y both sides first, and then we're going to get, so we have y sine 50 degrees equals 15, and then to solve for y we're going to divide both sides by sine 50. Okay, remember sine 50 is just a number, so we can divide both sides by sine 50. And that cancels, we get y equals 15 out of sine 50. So that's what we need to type into our calculator. So let's go ahead and do that. 15 divided by sine 50 degrees. And that gives us about 19.6. So y is approximately 19.6, and check my units, 19.6 centimeters. This makes sense because it's the hypotenuse. It should be bigger than the 15 centimeter side. Okay, so I'm going to, so that was 19.56, yes, 19.6. So that's my answer in centimeters. Okay, let's take a look at a couple other examples. So let me rewrite SOHCAHTOA up here. SOHCAHTOA. That's all you need to remember. So in this triangle, we have the 65-degree reference angle. Of course, 5 centimeters is the 5 meters is the hypotenuse. This side over here is the opposite. It's opposite to the 65-degree angle, and x is actually next to the 65-degree angle, so it's adjacent. So in this question, we have adjacent and hypotenuse, which corresponds to cosine. So we have cosine 65 degrees equals adjacent divided by hypotenuse, which equals, and the adjacent in this case is x, hypotenuse is 5, and that's equal to cosine 65 degrees. And this is the equation we need to solve, so we're going to solve by multiplying both sides by 5, and we get x equals 5 cosine 65 degrees. And we're going to use our calculator to get the approximate answer of that. So 5 cosine 65. So 5 times cosine 65 equals approximately 2.1, which kind of makes sense in our diagram here. Should be less than 5. 2.1. So that's going to be 2.1 meters. Okay, in the next example, here's our reference angle is 50. Okay, so this side is the hypotenuse, obviously, and this over here is opposite the 50-degree angle, and this y value here is the adjacent. So we have adjacent and opposite and adjacent in this case. So that would be TOA, the tangent function we're going to use. So tan 50 degrees equals opposite divided by adjacent. Okay, that's going to be 20 divided by y. So we're going to multiply both sides by y. We get y tan 50 equals 20. And to solve for y, we're going to divide both sides by tan 50. Oops, divided by tan 50. Okay, and then we get y equals 20 out of tan 50, which approximately equals, so we're going to do 20 divided by tan 50. 20 50 divided by tan 50 equals 16, about 16.8. 16.8. Let me check for units. Centimeters. Okay, 16.8 centimeters. Okay, and we have one more problem. This is a word problem. So it says a ladder leaning against a wall makes an angle of 74 degrees with the ground. If the foot of the ladder is 6.5 meters or feet from the wall, how high on the wall is the ladder? So let's draw a picture of that. So here's the wall. Should have drawn that a bit straighter. Okay, there's our wall. And the ladder is leaning against it, so let's draw that. The ladder, okay, so this is at a 74-degree angle. Okay, but notice this makes a right triangle. And the foot of the ladder is 6.5 feet from the wall, so that would be right here, 6.5 feet. And the question asks us how high on the wall is the ladder. So that's going to be the unknown value that we're going to find over here. Okay, so if we look at this triangle, here's our reference angle, 74. Okay, here's the hypotenuse, obviously. So with reference to 74, this is the adjacent side, and x is the opposite side. So if we look at SOHCAHTOA, our trigonometric ratios, SOHCAHTOA, which one do we use? We use the one with opposite and adjacent. Opposite and adjacent, that would be tangent function. So we're going to use the tangent function. We have tan 74 degrees equals opposite divided by adjacent, which is x divided by 6.5. So I'm going to multiply both sides of the equation by 6.5. And I will get x equals 65 tan 74 degrees. Okay, I'm going to work that out on my calculator. And we have 65 tan 74 degrees is about 226 point... Oh, I made a small error. Hang on. That doesn't make sense. That's way too high. This is 6.5 feet in the question, so that should be 6.5 tan 74. So let me do that again. 6.5 tan 74 equals about 22.7. So let's say that's 22.7 feet, and that's your final answer.